Let's go over this code. So first thing to do is includes, which you just find out via trial and error, and then this is quit handle code, which Professor Blanchard had given to us in Slack, so we could kill our program. Our program could handle receiving a kill signal. We'll get back to this emit code later, and more code for the kill signal. These are pointers to handle calls to functions that we'll start talking about right now. So the first function is to create a session with the libUSB. So once we actually create a session, then we can get this device list, and we'll see all the devices that are connected to our computer. And one of these devices will be the virtual USB device. So now that we have this device list, since we have gotten the device list, now we can open up the virtual USB device using the virtual and product IDs that Professor Blanchard gave us right here. So we open up this device by making this function call, and then we free the device list because we do not need it anymore. And we create a data variable to hold the data that we will begin reading from the virtual USB device. So once we get the virtual USB device, or once we open it, we have to claim an interface, and that just tells the operating system that our application would like to have ownership of this interface. So we need to claim the interface before we do any I/O operations. And then, now that we're connected to the virtual USB device, we need to work with the U input module to connect to the JS0 file, which is where we'll be writing to. So the JS0 file will be automatically connected to if we connect to the dev/uinput device. So we connect to dev uinput, and it'll automatically start writing to JS0 when it sees the BTN joystick event. And we need these IOCTL calls to sort of declare this event and allow us to use these specific events. So with this call, I'm allowed to use the event type EV-key, and with this call, I'm allowed to use the event BTN joystick. This is for event type EV-abs, and these calls are to use the event types absx and absy, which we'll need to transmit axes data. And then there's some other setup here that's specified in the uinput tutorial. We need to specify that we're using the USB bus. And so now, after this, we've connected to the JS0, and we're supposed to set these absmax and absmin values. I saw that in a Python tutorial. I think it will work without them, but better safe than sorry. And then, now that we've actually connected to both the uinput module and the USB virtual device, we can use this interrupt transfer function, and we pass in the data variable so we can read to it later. We have this endpoint, which you could see in the device list if you print the devices, that this is the endpoint we're supposed to use. Do some bit operations on the data to get it into the values that we want to write to JS0, which are the ones that Professor Blanchard specified. So once we do that with these operations, we can actually write them with the emit function. So let's go back to the emit function. All the emit function does is creates an input event and updates its fields, and then writes it to the specified file. So it's going to write to the JS0 file, and then once we receive the kill signal, quit, our while loop will finish, and then the interface will be released, and we'll close the device and we'll exit the session. So now let's try out and try to test some stuff. So JS test, you can see there are no values, or it's the beginning values. So let's check now. And now we have our values. So the button's on. This is the right value for Y and X. Button's off. Let's flip the values. So the button is off here and the values did flip. So everything's working great. All right, thank you.